So for this topic, I'm going to be talking about how you can use the z-table and relate it to the normal distribution and use it to find your percentage values for how likely something is to fall either above or below the mean by some value. So first of all, let me go ahead and draw the normal distribution as best I can anyway. Okay. So the mean would be perfectly right here at 0. And then as we go left and right, out by 1 standard deviation in either direction, 2 standard deviations in either direction, and 3 standard deviations in either direction. Okay, so before I even look at the z-table, let's remember some stuff about the normal distribution. First of all, the entire area under this curve, if you went in both directions forever, is 100%. However, you do have to keep in mind that when we get to using the z-table, it's going to give you everything in terms of almost there, basically. So the lowest my z-table has is negative 3.4. Yours might be a little bit lower, or it might just a little bit higher, might stop at negative 3. But as long as you know that the whole thing is 100%, you can find at least approximations for anything you need. So the other thing to keep in mind is we know that half of the graph is 50%. So if we ever have a positive z-value, we know that it should be more than 50%. Likewise, if we ever have a negative z-value, we already know that the area under the curve should be less than 50%. And so that's a good way to check your work. Another thing is often the area under the curve is going to be referred to by alpha. So you can keep that in mind. If they ever talk about what is alpha, they're basically asking you what the area under the curve is. And one more thing, in this z-table, you're going to have decimal values. So you got to make sure you're comfortable with converting from that to percentages if they ask you for that sort of thing. So let's say we had a particular value such as z equals 2.1, 2.13. Why not? So first of all, that would be about here. And also notice that's a pretty big z-value. So let me use the green. That's going to cover majority of the graph here. So if I go to the z-table now, the way this works is that when you look at your rows, the rows are going to list your ones place and your tenths place. And so you're going to look up 2.1. And then what you'll do is you'll look at the columns for 3. So I'm going to go ahead and look at my z-table here. I'm going to find 2.1. And once I found that row, I'm going to go over to 0.03 in the columns. And so if I do that, I'm getting a value of 0.9834. So the total area under the curve, alpha, when z is equal to 2.13, is coming out to be 0.9834. And recall I mentioned that they're going to give these to you in decimal values. If you're asked what the percentage is, this percentage is going to be 98.34%. So that's just for this arbitrary z-value I chose of 2.13. Now, let's suppose you had a different z-value. Let's say z equals negative 1.8. And let's make it negative 1.80. So that would be about here. And so that's quite a bit less of the graph you're noticing. So let me look in the z-table, see what I get. So I do the first 2 places. I'm looking for negative 1.8. And then I do 0 in the column, so it should be the one right next to it. So if I look at this, alpha when z is equal to negative 1.8 is giving me 0.0359, which if you convert that to a percentage is 3.59%. Now notice that this z-value was not as negative as this z-value was positive, and then look at how much of a difference you've got in the percentages here. Well, in general, the smaller your z-value or the more negative, the smaller the area under the graph is going to be because you're looking at all the data that's over here, and that gets really small really fast. The bigger your z-value is, the more area you get. And notice that happens quickly because since the normal distribution is going up, as you move over, you don't just get like same multiple segments. You don't get like bricks getting added on of the same area over and over. You get a much larger area very quickly, and you have all of that below this z-value. And so when you're using the z-table, It's pretty easy. You just look at your z-value, look at your row, look at your column, and pull up the area. The only thing you have to be careful of is sometimes you might be asked for the area above a certain z-value. And so the z-table is nice, but you do have to understand what they're asking for and how it relates to the normal distribution. Because while the area underneath z equals negative 1.8 is 3.59%, if you had been asked how much of the data falls above a z-value of negative 1.8, well then you have to remember that all of this area is 100%. And since the z-table gives you area to the left, what you would have to do is you would have to go, okay, 100% minus this bit, right? Because I don't want this, I want everything to the right over here. So I'd have to do 100% minus the 3.59%. And so that can be really tricky. So that's going to be 96 point, I believe that's 41%. Yeah. So that would be all the area above a z-value of negative 1.8. And the z-table doesn't have that part, but it will give you this, and if you know that that's how the z-table works and how it relates to this normal distribution, you'll be set. And that was today's topic.